Hi everyone, welcome back to another video. So in the last video we went through a quick look at my modules that I'm studying next year. This is what we got through. So it wasn't great. I basically didn't understand almost anything. And what's funny is actually I had one of my fellow classmates, he messaged me today asking me if I knew what instrumentation and control was. And I literally said that I made a video on it yesterday saying that I have no idea. So neither does he. So we're going to take a deeper look into the modules today and try and see if we can get an actual understanding of what each module is about. So let's go back to here. So I'm working in my Notion. This is what I use for all of my, basically I document most of my life and organize my life on here. So, all right, so let's start a new page. Okay, and then we're going to make a page for each module. So, yeah. Okay, so we've got each one of the modules here. Let's turn this all into a page. There you go. All right, we've all got icons now. Make them look pretty. Let's give this one an icon as well. There you go. All right, so let's start with embedded system. Okay, so what I want to do is I'm gonna look to see if there's any lectures for one. Then I'm gonna look to see the reading list, the recommended reading list, and then I'm gonna get some information from Google on, well, let's put subjects from Google. Okay, so let's take a look first to see if we have any lectures available for embedded systems. So this is on my university website, right? We would have them on this left side here, but there aren't any. Okay, so let's go to the reading list. So the reading list is set out by the lecturers, and they basically let you know what books you should read for the module. And actually what I'm going to do is I'm going to do reading list subjects, and then let's put like all subjects from reading list. The lectures, none, reading list. Or for my uni, they put like essential, recommended. So essential is like basically what you should 100% read, and then recommended is like you don't need to read it, but it'd just be good if you did. So we've got an essential one here. So fast and effective embedded systems design, applying the ARM embed. Okay. Let's look at some reviews on Amazon. 38.57. That's got good reviews. Okay, let's see if we can find a PDF of it. PDF. Okay, so looking at the description of it on Amazon, it looks like I've got a PDF downloading, so we'll see if that works. It says this title provides a hand-on instruction to the field of embedded systems, a focus on fast prototyping of embedded systems, all key embedded systems concepts covered through simple and effective experimentation, an understanding of ARM technology, one of the world's leaders, a practical introduction to embedded C. I thought so. So it's going to be C programming. C programming on ARM technology, okay, and applies possibly the most accessible set of tools available in the embedded world. This book is an introduction to embedded systems design using the ARM, Embed, and C programming language as development tools. That's fine. Okay, looks like the PDF's downloaded now. So I've got the whole book here, which is nice. Embedded systems, microcontrollers, and ARM. This is good. This will be a good topic because I've already covered the ARM processor in my computer systems architecture module from last year. Introducing the embed, digital input and output, analog input, code programming techniques, starting with serial communication, liquid crystal. Okay, so let's do this, right? So we've downloaded this already, right? Okay, so I'm just going to save it into my Dropbox. 2021 second year. Let's put embedded systems, and then we'll put books. Okay, so we've got that there. Then let's open up Notion, and then let's put. Alright, so I've uploaded the file to my Notion, so I'll have easy access to this file wherever I am, which is good, so I can read through that book. I want to get a good list of the subjects for here, so let's just copy and paste some of these. Just the overview of what it is. So microcontrollers and ARM. I actually feel quite confident with this. So the purpose of me making up this now is basically for me to, get an idea of some of the things that I should be, reading or studying whilst, in preparing for the second year. So I've got about 3 weeks now. So some of the things that I should be studying. It just gives me like now I obviously know a lot more about what it is I'm going to be doing. It's going to be a lot of C programming and it interacting with the hardware, which is what I thought it would be. I don't think I'm going to get this deep into it. Letting go of the embed libraries, hardware insights, clocks, resets, and power supply. Okay. So that's cool. So we managed to get the book and some chapters down, which is alright. Alright, let's take a look at Designer's Guide to the Cortex-M Processor Family Tutorial Approach. Embedded Systems Volume 1. Let's have a look at this one. Let's Google this one. See if we can get a PDF for this one. Nice, okay. So I found a table of contents. Introduction to computer electronics, introduction to embedded systems, applications involving embedded systems, product lifecycle, ARM Cortex-M processor, ARM Cortex assembly language, post development process. So I've covered all of this already. Introduction to input output. That's 4. Chapter 5, modular programming. Chapter 6, pointers and data structures. Chapter 7, variable numbers and parameter passing. Okay, so I think this module is going to be, I mean, I shouldn't say this now because I end up failing it. That'd be funny, but I think this module will be a breeze. Oh look, it looks like I have the whole book here. Nice, looks like I've downloaded that book as well. Nice, yeah. So it's not in the pretty form, but that's ARM assembly language. I know I can spot that straight away. Yeah, all right, that's nice. So I've got another book as well there. Let's just save that into the folder. I think this embedded systems one's going to be a breeze for me. Shouldn't be a problem. Cool. Okay, so let's move on then. I feel like we'll do a bit of googling just as to what embedded systems is about generally, and let's see if we can find some subjects. So embedded systems course. Embedded systems characteristics and requirements. Unified modeling language, instruction set architectures, compilation techniques, power aware design, hardware accelerators, embedded system network, and design methodologies. Okay. Let's just copy and paste this in here. Definitely, it's one of those ones as well. Like if you just studied this, if I spent a week, touching each one of these subjects, maybe if I just read a chapter a day on each one of these subjects, by the time I start my module, I'll be flying. It'll just, the lecture will be explaining things, like as if for most people I've never heard of it before. And, not only will I seem like a wizard to most of the other kids in the class, but it will give me confidence that I'll be able to understand, I'll know where he's going with things. And I did that last year as well. I read ahead, even I was reading the chapters and I was like, what? I don't even know what this author's talking about. But let me just glance through the chapters, and I did it. I didn't read every word, but when you just read a couple sentences per paragraph, get through like 10 pages in 5 minutes. Nice. I just want to find like a more general overview of what's taught. Okay, here, what are the subjects related to embedded systems? Here we go. This is what I was looking for. Perfect, absolutely perfect. So, processor architecture, embedded C, C++, interface and input-output devices, operating system concepts, domain knowledge. Love it, absolutely love it. Look at that. This is exactly what I wanted. Brilliant. Aura, man, you just can't put a divider. Very happy with that. There you go. So for me to learn all of this will probably take me 2 years to learn. So that's more than enough. I'm very happy with that. Okay, cool. Look at that. So now I can easily, thoroughly say to you that I know what embedded systems is going to be about. Cool. Okay, so that's that one done. All right, let's do the next one. Electronic and electrical principles 2. I kind of already have some books on. So sadly, no lectures again for this one. I kind of have already a decent idea for what I'm going to be going through. So I've already got these books It just seems like basically more of the same. Yeah, I've got these books already. Let's just find them in my Dropbox. This is another thing that you want to remember is you wanna try and set up whatever file storage system you're using. You want to set it up beforehand. Have all of your modules. Make the folders. The last thing you want is to be saving all of your files on a random USB stick all over the gaff. You set up a Dropbox or a Google Drive and do this. Alright, so let's take a look at this subject used in this. Like I said, I already have an idea of what we're going to be going through. So we've got introduction to electrical circuits, resistance variation, batteries and alternative sources of energy, and series and parallel networks, current division and potential analysis. But definitely I need to go over capacitors and capacitance because we didn't cover that really at all. I don't really know what exactly we're going to cover. I assume we might cover AC. I can't imagine how we wouldn't. How far are we going to go into all of this? Like, this is a lot. Look at this. 40 chapters. 45 chapters. Okay, so potential divider, parallel networks, current division. I mean, obviously I've already covered all of this. I'm fine with that. Okay. Let's start. We'll start with capacitors and capacitance. Okay, so this is too much of a long list. It's impossible. I'm gonna be able to get through all of this. Again, like I said, I kind of already have an idea of what I need to study with this. Guess it's gonna be like mostly AC and capacitors and inductors. Inductors aren't on here. But that's what I feel like. Definitely these three, because this is a long list of stuff, and I don't think I'm gonna get through that. But definitely these three, if I can cover them ASAP, then that would be ideal. Okay, so let's just this is a bit of an obscure module, so I don't know if I'm going to be able to find anything on it on Google. Okay, so nothing on Quora. Okay, I'm happy with that. Communication systems, bloody hell, mate. Literally no idea what this one is. So hopefully, please have some lecture slides. Again, no lectures. I don't know why. Like, I wish they would just release the lectures. Like, imagine if I just had the lectures now. I'd know exactly what I'm going to be taught, and I could prepare. It'd be it's frustrating. It is frustrating. Okay, so let's take a look at the reading list. I knew that most of them wouldn't have lectures, but I thought, I put the lecture head in there because I thought some of them might. Nice. Okay, so we've got two books, basically the exact same books. Pearson 2015, that one, and 2015. Yep, same exact books. So apparently I can access the book, which is nice. Okay, so I think I can read it online and then look at the table of contents from there. Alright, so let me copy and paste this link into here. Prin embed and table of contents. Okay, nice. I'm happy with this book. I'm gonna probably make this a priority because I'm looking at this list of stuff here: channel capacity, multiplexing, circuit switching, packet switching. Mate, zero. When I say I have zero idea what any of this means, zero. So at the moment, this is going to be the module to fail, really. You know what? Look, I'm super happy about that. That's just giving me a whole bunch of stuff that, I really didn't know what this was going to be about. Okay, so let's do the whole Quora search and just say what subjects are in. Okay, so it is also a basic and foundation subject of electronics and communication engineering. Students learn about basics of wireless communication from AM, FM, PAM, PCM to advanced communication like systems like mobile communication and different wireless technologies. It's a basic subject if a student wants to get a job in communication systems. I definitely do not want to get a job in communication systems. However, you know, I would like to be, you know, a decently well-rounded electrical engineer. At least to the point that, you know, I could Google it and understand what I'm reading. At the moment, most of these words are just jargon. Choose if and only if you are at least average at maths. Okay. Subject has boring practicals, but it's one of the promising fields. If you're good at maths, then you're going to love the subject. I am not good at maths. I mean, that's not true, but I'm not up to scratch with maths, let's say. Okay, this seems interesting. Copy and paste that in. I feel a lot better about that, you know. A lot better actually. It was a bit scary to hear that this is gonna be maths heavy, but you know, actually quite looking forward to that. Let's just see if I can download this book as is, because at the moment I've got access to it via the university. Let's see if we can get a PDF. Okay, so I can't seem to find PDF for it. Okay, so it doesn't seem like I can find this book. That's fine. Cool. Okay, fully give up with that one. That's fine. Like I said, I can read it on using my university anyway, so that's cool. I'm right with that. So let's move on now to the communication systems is done. Alright, so instrumentation and control. So let's get cracking with instrumentation and control. So let's check lectures. I've just in the last minute of the video, I've taken a 5-day break. So hopefully some lectures have been released, which if they have, we'll go back and update some of the previous modules, but let's take a look anyways. All right, so we are doing instrumentation and control, nothing lectures. Okay, take a look at the reading list. Okay, so we've got an essential book, which is Engineering Mathematics, Foundation for Electrical Communications Systems. So this is instrumentation and control, and they're recommending mathematics book. Okay. All right. I don't really know what to say here. This is not great because this is just going to be maths, right? Literally, it says a review of algebraic techniques, big functions, vectors, just maths. Okay. But that's a bit useless to me. Okay. Block 1 instrumentation, block 2 control. Okay, there we go. Nice. Okay. I was confused there. Common resources. Okay. So the math books, ignore that. That's under common resources. That's fine. So then it says instrumentation. The reading in this section relates to the first part of the module related to instrumentation. Okay. And then practical electronics for inventors. I believe I already have this book. Okay, so let's see what the book's about. Mechanisms of voltage, water energies, applying a voltage, earth ground, Kirchhoff's laws, inductors, Thevenin. So I mean, none of this is useful. Capacitors, inductors. There's a big crossover there between this and the other modules. So hands-on electronics, maybe? No. Join a sec. Let's go electronics laboratory. Alright, so this book is useless as well. Okay, so he's got that book marked as essential, which I'm confused by. Because we've already learned all of that already. So I don't see what there is to learn there. Okay. So mechatronics, electronic control systems in mechanical and electrical engineering, 7th edition. Put it down as essential. It's got mechatronics. So it seems like this word, I don't know what mechatronics is. Mechanical electronics? Is that? Let's check what the word means. I mean, you'd think it would mean mechanical electronics, right? which is also called mechatronics engineering, is a multidisciplinary branch of engineering that focuses on the engineering of both electrical and mechanical systems. Booyah! Got it right. Okay. So instrumentation seems to relate somehow to mechatronics. All right. And then he's recommending we read about sensors, fundamentals of sensors for engineering and science. All right. So I think I'll try and find these two books, the Mechatronics, Electronics Control Systems, and also the Introduction to Mechatronics. So let's W. Bolton. So we got an Amazon, Pearson, W.H. Smith, ebooks. Okay, Drive PDF. Seems to be a popular book. PDF Drive, book PDF. Haven't available. Oh, it says sorry, this file has been deleted due to copyright infringement. That's how you know they don't want you knowing about it. Okay, that's an old book in 2003. Can't really be reading 2003 books as it relates to this, I assume. That's a nice cover, that. Download start in 23 seconds. Nice. Hopefully. Alright, so it looks like it's downloaded. Let's have a look. Nice. Mate, that is a nice front cover, isn't it? Like, front covers should look like this. That makes me want to read that. You know what I mean? Like, of course, there's that's not real at all, but it looks nice. Okay, so mechatronics. So we're just trying to get a gist of what my lecturer wants me to learn about. So introduction to mechatronics, sensors and transducers. So that's interesting because obviously he's mentioned here that there's other books, fundamentals of sensors, understanding smart sensors. So it seems like sensors is going to be something that I'm going to be learning about. So that's force, fluid pressure, liquid flow, fluid level, temperature, light sensors. Well, I kind of already know this stuff, so that's cool. Signal conditioning, digital signals, digital logic. Again, kind of okay with all of those. You know, Wheatstone bridge, pulse modulation. These have kind of all already been covered last year, so I don't know if it would be worth going over these again, or you know, going into this kind. I mean, even assembly language done that, C language done that. Have some experience with microprocessors and microcontrollers. Actuation systems, nope, no experience. Yeah, not really. Data presentation, nope. Pneumatic and hydraulic actuation systems, nope. I mean, this actually just does seem interesting, the whole book, really. I think I may put this on like my list of, I may just put this on my, you know, reading list in general. Seems like a cool book to read. All right, so let's save the book. Try and see if we can find the other book that he mentioned. Apple Kutan, Introduction to Mechatronics. So mechatronic systems, mechatronic manufacturing, electronics, mechatronics, computer elements, system modeling and analysis, sensors and transducers, CNC machines, intelligent systems and applications. Download PDF file here. Drive.google.com. That's what I like to see. So, oh, it's a legit download as well. Introduction to Mechatronics, 346 pages. Love it. Love it. Okay. So, okay. So remember, this is all just part of the instrumentation part of it, right? So I feel like maybe I should make a bit of a difference. And then just do the same for control. There we go. So we've got control and instrumentation. Ah, interestingly, looks like he's notes for students. I didn't even see that. So he's got interesting, you know what? It's this lecturer in particular. I really like him. Proper detailed guy, man. You know, he does his job very well. I love it. So notes for students. In this module, we will be largely and deliberately ignoring the signal processing and electronics engineering required in the instrumentation and sensors used by the PLC control systems. Ignoring the signal processing. Okay. Okay. Used by the PLC control systems. Am I supposed to know what that means? PLC control systems? I'm sure before you use an acronym, you're supposed to... Okay, programmable logic controller. Alright. So, required in the instrumentation and sensors used by the programmable logic controller control systems. Sorry, that's a mouthful. However, this is a very important topic and at least some knowledge is required to have a comprehensive understanding of modern control systems. Dunn provides a good, if brief, overview of the key classical sensors you will find in most control systems. For a look at the more modern approach, see Understanding Smart Sensors by Randy Frank. Okay, and then in the Randy Frank book, this book looks at the modern trend towards smart sensors for use in hybrid and nonlinear digital control systems, and so complements fundamentals of sensors for engineering and science. Not intended, I should say. Not intended to be read from cover to cover, but a useful source of information for both the module project and beyond. Module project, interesting. So it looks like we're gonna have a project. Let's just put here note may be a project in this module. I like projects. I always do well on the practical side of things, you know, building physical things, so that gives me a lot of confidence. Okay, what I'm gonna say is I'm gonna find these two books and I'm gonna say that I should take some time to glance over the two following books. There you go. You can see, like, you know, I haven't learned anything, but I have an idea now of all the stuff I don't know about this module, which is cool. It's a nice place to be in. Like, when I sit in this class, I already have, when I sit in the class for the first time, even though it's not going to be in the class, it's going to be an online Microsoft Teams lecture. Anyways, don't get me started on that. But when I'm sitting there, I'm going to at least have an idea of what's about to be spoken about. So that's cool. Okay, so let's go on to control. Although I didn't touch Google, let's have a look on Google. The instrumentation and control. This seems to be most accurate with what I'm going to be doing. Oh, what's this? Computer programming, utilization, basic electronics. Let's just copy and paste this. I like this list. Let's move on to control. Don't get me wrong, you know, everything I'm doing here is a proper, like, tiring process, and it's a bit boring, I must say. Like, there's no way I'm sitting here enjoying this. But it's one of those ones where if you want to do well, these are the kind of things that you're gonna have to do. A bit crazy, and yes, nobody else does it. You're gonna be the only one. It doesn't matter. That's how you get good at these kind of things. So sensors, industrial, and then what I do as well is I actually just bribe myself with a pizza. So I say, look, you know, go through, do a deep dive into the module, and eat a pizza afterwards. So that might work for you. From second year onwards, you have electrical network, digital signal processing, analytical instrumentation, digital control systems, analytical control systems. So a lot of this stuff here says control in it as well. Okay. Face that. Control system something. DSC, what the? That's hilarious. All right. Okay. Fine. Okay, so the reading in this section relates to the second part of the module focused on control systems. The resources in this section focus on a background theory of control systems, and analysis. Okay, so he's got two of these books by Norman Nice. Control Systems Engineering, 8th edition, and Nice's Control Systems Engineering. What's there? One's the 8th edition, one's not, I assume. Okay. I like the fact that it's a 2017. At least it's like newish. Universities definitely need to make an effort to keep their reading list up to date. Really don't enjoy reading books from 2012, 10. Okay, this seems to be a very famous book, so I'm excited by that. The thing that I think about as well is, you know, when you've got interviews, wow, 1,000 bloody pages, mate. So this is 6th edition. 1,000 pages. This is a good book though. Look at this. I love it. I love it. I love seeing proper illustrations stuff. Love it. This is the 6th edition, so you're gonna assume that the newer edition is even better. What year is this? 2011 it looks like. Nice. This book is printed on acid-free paper. But yeah, I didn't know that was a thing. Alright, so definitely download this book. We've got 1,000 pages here. Mate, do not intend on going through 1,000 pages, but yeah. Okay, so download that. Save it there. Then upload it to our reading list here. Cool. Okay, so let's see if we can get the 8th edition. 40 quid for the ebook. Cheers, but no thank you. 7th edition. Download, looks like you can do that. And there's a 6th edition. 2014, so that another 2 years later. Okay. We got all the 4th editions and stuff like that. 2015. Is that the latest? 6th edition, 2015. The 7th edition, 2014. Oh, solution manual. I'll take that. I do not like it when they don't give you solutions to download this. That the 7th edition being downloaded. Sick. Absolutely sick. Then. Nice. 943 pages. Oh, mate. I'm in heaven. This is brilliant. Okay, so 7th edition. There you go. There you go. In there. I would really advise using Notion. It's nice. You know, I've used a lot of different things before, and you know, especially Evernote. But now, I mean, I got a notification yesterday from Evernote, or maybe the day before, saying you haven't logged on to your notes for 7 days. So I used to use Evernote all the time, but I've switched over to Notion now, and I definitely don't regret it. Okay. Let's see if we got the solution manual. Is that the solution manual? Definitely want that. Imagine how long it takes to do this, man. Just crazy. Cool. Okay. So, well, okay. I'm just trying to get the 8th edition, basically, right? And then after I get the 8th edition, then if I can't get it, then go off the context page of the 7th one. 7th edition again. There's 51 pages of 6th edition. Trying to do me short there. Okay. That's the 6th edition. So we were just looking to see if we can get the 8th edition, basically, right? 7th edition. Alright, so let's just look at the table of contents here. We've got modeling the frequency domain. That sounds interesting. I kind of have an idea what the frequency domain is. It was explained to me by my lecturer last year as being like a motorway of signals. Okay, and modeling in the time domain. Okay, that looks interesting. That. So let's put what subjects are in control systems engineering. Linear optimal control, intelligent systems, non-linear controlling systems, self-tuning and adaptive systems, manufacturing, automation, process control systems. That's at master's level. I am not doing master's level. Okay, can we just borrow it? What are the best reference books? What are the best books for preparation of gate exam? What are the raw application of subject control? Okay, so nothing of interest there. So let's say what subjects are in control. Okay, we'll go with this list here, even though this is a master's at Manchester Uni. Cool. Okay, so I'm super happy with that. I mean, that's a nice list of instrumentation and control, and I actually feel a lot better about the module. Let's just see if we've got any notes from the lecturer. Oh, so he's got a book on MATLAB, but it's only recommended. So I assume we're not going to be doing MATLAB in this. I mean, that seems like a bad assumption to make, especially because there's a PLC programming portion here. I don't think I'm done. I don't think I'm done with this. I thought I was done. I don't think I am done, especially because this background reading is saying recommended. So I'm going to skip that because there's absolutely no way with all these books I'm going to have any time to get to this. However, PLC programming, which is the programmable logic controller, if I remember correctly, has two essential books. Two essential books. Okay. Shoot me now, people. Shoot me now. Automating with schematic S7-1200, configuring, programming, and testing with step 7. What? Okay. So his notes are an alternative to the Siemens tutorials used in this module. You what? An alternative. Okay, so I assume we're going to be using some Siemens tutorials, and he's saying this is an alternative to those. Okay. This book covers much the same ground, but also has space to expand beyond the tutorial topics. As such, it provides a good complement to the Siemens tutorials, or indeed can replace them if you find this author more readable. I actually do have a big problem with authors, sorry. Some authors, I can't read their books. I need pictures. I'm a pictures kind of guy, okay? And I want to see pictures. So whenever I'm studying something, I like to have different options available to me because I don't want to be stuck with one author where there's no pictures, nothing, and I'm just expected to just learn what he's saying. So I'll definitely be down. Oh, 577 pages, and I got the whole book. Nice. What's the difference here? Step 7 professional. I look for a year. So that's second edition. What's this one? 2014. Nice and new. I like that. I like that. What's this one? Second in large. 2013. What happened there? Second edition. Okay. So what's this? 2014. But there's no mention of edition. Okay. So this is the new one. Anyways. Let's just download both of them because why not? So 577 pages and 832 pages now. Okay, so we got both. So now let's put them where we're going into control. Or no, these are in a complete different part. We should actually make a different one, PLC programming. Okay, so let's do that then. PLC programming, and then let's put the two books in there. Be this. Okay, so these two books are alternatives to the tutorials used in class. Cool, that's fine. Okay, so Programming Logic Controllers by Bolton. This textbook covers the core theory and operations of PLCs with a little bit of the background on control theory. If you have no background in digital control, bloody hell, who does, man? If you have no background in digital control, how many students would have a background in digital control? Okay. Then the early chapters will also serve as a useful starting point. So I basically need that. All right, let's read this third book by Practical SCADA. We just completely butchered that for industry. This book covers a very large area of PLC control that is outside the scope of this module. Outside the scope of this module. So it's outside my scope then. If it's outside the scope of the module, it's outside my scope for sure. Okay, but links into some of the core themes, especially those developed in the project. In most control systems, the core human interface to and from the plant. Power plant, you mean? Power plant as in factory? I don't know. I assume it's not plant as in one I have on my desk. Is via supervisory control and data acquisition or SCADA system. Supervisory control and data acquisition. SCDA. SCADA. Ah, okay. Got it. So supervisory control and data acquisition is abbreviated SCADA. Okay. In recent years, the scope of the SCADA system, yep, has also expanded beyond the core human interface to become part of the machine-to-machine interface. If you're interested in the broader context of PLC control, this book is a good place to start. I'm going to skip that one, and let's just try and see if I can get this book on bolting on the programmable logic controllers. I got it. Nice. It says it was new as well. Beautiful. Yes. Super happy about that. Okay. So, cool. And what was said about this one for this book? Covers the core theory and operations of PLCs. And what does this one do? Alternative. I've already written that there. Okay. Cool. Yeah. All right. So I'm confident now that I mean, I'm confident. Let me actually scroll to the bottom of this page first. Okay. Yeah. So I'm at the bottom of this page. Practical SCADA for industry. Yeah. So this looks like an interesting module. I actually quite look forward to this one. So where are we at now? So we've done electrical principles 2, we've done embedded systems, communication systems, and instrumentation and control. I like this. You know, I did get the feeling after my first year of electrical engineering that I didn't really do that much electrical engineering. I mean, digital electronics was a bit of a flop for me with COVID and stuff, and I felt more like a programmer. So I'm excited for these modules. You know, embedded systems, I'm still going to probably feel like a programmer, but so far, electronic and electrical principles 2 is going to be obviously electrical engineering. Communication systems definitely electrical engineering, and then now it looks like instrumentation and control. Again, this is, you know, a lot of, you know, I like it. Look, digital logic, digital signals, programmable logic controllers, control theory. It feels like a lot of electrical engineering stuff. I like. So I'm guessing the design project is going to feel more like robotics. Kind of got an idea. I think I actually know what robot we're going to be using as well, so that's fine. And then analog electronics is going to be, obviously, you know, I'm looking forward to that proper analog stuff. Using it, well, with COVID, I mean, am I even going to get to use an oscilloscope? Who knows? I'm going to have to buy one myself. All right, cool. Yeah, so we'll move on now to engineering design project 2. Let's just make a folder, Dropbox for it. So I was actually very clever. I asked my lecturer last year after the engineering design project 1, I said to him, what would the robot be on for the next module? So he actually told me, thankfully. Change this logo. Robot. There you go. Alright, so it's gonna be on Lego Mindstorms EV3. There we go. This is the robot that the project's gonna be based upon. But Lego, type it into Amazon, get it up and up. I wonder if they're gonna give us our own one, because it's very expensive, 300 quid. But to be fair, I mean, so it's 9.5 grand for 1 year of university. So there's a robot with an infrared sensor, color sensor, touch sensor, 3 interactive servo motors to move, remote control, programmable brick, the brain and voice of your robot. Got a lot of good ratings as well. Look at that. And even solve the cube. That's cool. But he's got it solving it. Rubik's cube. That is genius. That is absolutely fantastic. That solves it quick, right? He's done. Wow. In 22 moves. That is amazing. Okay. Alright, so program your robots with the free EV3 programmer app. Buildable robotic systems with unlimited options. Nice. So if it is still based on this, I'm excited for that. That's cool. So let me put this. So it should be based on the Lego Mindstorms EV3 robot. Alright, so okay, so let's just take a look at some videos for it. Okay, that's cool. Oh yeah, I've seen this video. I think this is in their store. It's so cool that Lego actually do something like this. Yeah, I really look forward to this module. Alright, so this could all be completely wrong. So let's actually take a look at my module. Engineering Design Project 2. Yeah, no lectures, that's cool. I have a feeling that the reading list is going to be exactly the same as last year. Yeah, practical electronics for inventors, electronics. So it's just like the Make Electronics books. Okay. Yeah, so this module, similar to electronic and electrical principles 2. Because I studied it last year, I know what the module is going to be about, basically. However, there's not really much that I could really do to prepare myself for it, other than just do quite a fair bit of C programming. Because I assume you're going to program this in C. Okay, maybe I could try searching for this Google and see if anyone's old lectures come up. Ah, there's this. Okay, so the Lego Mindstorms EV3 laboratory build, and it's got it as essential. So okay, so I'm yeah, I think I'm right about the Mindstorms EV3. Let's get this book. I might be at there. But there's another one there as well, actually. 436 pages. That sounds about right. Okay. Memory of Nari. Okay, so the set, building a rover, programming, advanced programming with a brick program app, EV3 programming, the math behind the magic. Okay, so it looks fairly straightforward. I mean, building a T-Rex. My kids would love that. That's cool. Okay, so I'm just gonna jump to programming just to confirm that it is C programming. I was just talking about algorithms and pseudocode or whatever. Boiling a cup of tea, flowcharts. Yep. The left program. Wow. So isn't like kids programming with blocks? That's a bit rubbish. The brick program app. Okay. I can't imagine that this is what my lecture is going to allow us to do. Weight blocks, action blocks. Forward at 100% power, forward at 50% power. I mean, if this is it, like, that's a bit easy. I mean, it seems like, oh yeah, it does seem like that's what it is. There was no mention of any C code there. C programming. Nothing about C. Let's do tag include. Nothing. Okay, maybe this book is for kids or something. But then the lecturer's he's recommending it, so okay, so let's do C programming. Yeah, look, so it's coming up straight away. Alternative programming languages for Lego. Make code, Swift Playgrounds, Python, Scratch, LabVIEW. Okay, that's what we did last year. Am I missing C? I'm still not seeing C. Yeah. Unless we're gonna learn Python, which I'd like to learn, so I wouldn't mind that. As for just using like, block programming, what would be the I don't. Okay, how to program Lego Mindstorms EV3 using C language. You can find the EV source code here. Generate documentation from the source code available here and here. Let me develop since C. Robot C. Oh, okay. Maybe I missed that. Is that here? There we go. Okay. Robot C is a C-based programming language with fully integrated software debugger that supports a range of different hardware platforms. Extensive documentation and online support is available for more information. Yeah, okay. So that's what I'm guessing we're gonna do. We're gonna program in robot C. And I don't know how beneficial it's gonna be to put on your CV that you can program in robot C. But yeah. So let's put seems like we'll be programming in robot C. But more, this is what I like about Notion. So you can do this, right? And then put that in there and hide it. It's cool. Okay. So I feel, I mean, I don't see me having any problems whatsoever with this. Oh, this guy's got a robot C and the sensors video. And actually someone else there had the instructions to see. Let's just see programming general. Okay, let's take a look at this guy's video. Task main. I mean, what language is this? I don't. Pragma config. Oh dear. So it looks like robot C is not C. Wow. Okay. So we recognize that. Still get semicolons there. Okay. All right. I'm not too excited about programming in robot C, but that's fine. Anyways, as I've said already, I don't think I'll have a problem with this, so that's cool. Feels a bit bland to just stop here and say that, okay, this is all we've got. Like to, okay, so I think for this module, I'm just gonna have to check back in a few weeks' time. So I'm due to start uni in 2 or 3 weeks. So I'll check back in a week or two and hopefully there'll be more information about this one. Although I kind of doubt it. The one thing that you want is that once university starts and you have an induction week, usually they have to post then all of the assessment briefs for how you're going to be assessed for each module. So once that's posted, then you have, you know, a real solid idea of what you're actually being assessed on, which is always, you know, always nice. Which is always nice. Okay, so let's move on to the next module now, which is the last module, analog electronics. I'm actually really looking forward to that module. I mean, I really am looking forward to this one. All right, so let's continue. We're going to create a folder for analog electronics. And so this is the last one. So analog electronics. Let's go on modules, analog electronics. And again, no lectures for now. Go straight to the reading list. Once the lectures are released, I'll add them in here. Reading list. Recommended. Okay. So that's not very useful. They're all recommended. Okay. So not really sure what to do here. Okay. All right, let's maybe try download this one. Let's maybe try this one as well. Electronic system level design, an open source approach. Okay. Analysis and design of analog integrated circuits. All right, let's try to go through these ones. So that might be a PDF right there. Analysis and design of analog integrated circuits. How many pages are we dealing with here? Did yet? Contents. I mean, this is ugly to look at. I assume it's a scan. There's even a tick there. Depletion region of a PN junction. Large signal behavior of bipolar transistors. Small signal models of bipolar transistors. These guys get straight into the mix. I'm not messing about. Alright. Bipolar, MOS, big, or BiCMOS. 889 pages. Nice. Let's take a look at what some of the content is on. Internal amplifiers. Yeah, I need to learn this. I look forward to this. Really do. Like, I look forward to knowing, just looking at that and going, oh, that's an op amp or whatever. I'm not saying that's an op amp. I'm just saying that's an example. Yeah. Okay. All right. So download this one. I'm happy with that. Let's get in electronics. Then we will upload it here. Okay. Let's take a list of some of what they're going through here. Okay. So models for integrated circuit active devices. Depletion of region of a PN junction. Large signal behavior bipolar. Okay, so let's do bipolar transistors. Supposed to have learned about this in digital electronics, really. Small signal models of bipolar transistors. Small signal models. Large signal behavior of metal oxide semiconductor field effect transistors. MOSFETs. Large signal behavior of MOSFETs. Small signal models. Okay. Even these words are confusing me. Short channel effects in MOS transistors. Okay. So let me just do MOSFETs. And let's do MOS transistors. Are they different? Bipolar, MOS, and bi-CMOS. Okay, so that's just what I've just written here, right? Other than bi-CMOS. Okay, single transistor and multiple transistor amplifiers. So amplifiers, single and multiple. Okay. So it seems like it's the main chapter heading I need to be looking at. I was a bit confused with all of this subheadings. Current, mirrors, active loads, and references. Okay. I know what a current mirror is. So that sounds cool. Active loads, kind of. Okay. Output stages. Op amps. Oh, look, maybe I was right. Maybe I was actually on. Imagine if I was actually on op amps as well. Op amplifiers. Okay. With single-ended outputs, could just leave it at that. Frequency response of integrated circuits. What I'm going to do when I actually start studying, I'm going to turn these into pages. So I'll give you an example, right? So what you can do is you can go here and then go turn that into a page, click on it, and then now I can start saying this chapter in the book is really cool. I'm loving it, love it, fantastic, love it. And you can go back and then still got the whole page here, and you can turn those into specific pages, and you can obviously put all your study notes and stuff in there, which is cool. Okay, so feedback. Now I've already put frequency response now. I have here frequency response of integrated circuits. The frequency response and stability of feedback amplifiers. Okay. Feedback amplifiers. And I'm just gonna stop here. Non-linear analog circuit. Oh, it's the last part anyways. So fully differential operational amps. So fully differential op amps. Cool. Okay. Alright, so let's find the next book. So electronic system level design and open source approach. So I assume these are written by like Spanish authors, Portuguese maybe. That's a PDF. There's nothing. Okay, that's fine. So we'll skip that one. And then analog integrated circuit design. Tony Chan. PDF there. 822 pages. Love it. No, I just want the paper. Yes. So analog integrated circuit design. This is the one. What year was it released? 2012. There you go. I was a bit blind. Okay, so let's just go to the table of contents and do roughly the same thing. So integrated circuit devices and modeling, semiconductors and PN junctions. So although I kind of know what that means, we'll just put it here. Semiconductors and PN junction. Right, have I saved this book? No. Save it. Upload it onto. Oh, come on. Okay, so MOS transistors, device model summary. I'm really looking forward to this module because I'd say there's like there's 3 modules this year that I don't really know anything about, and this is one of them. Like, I'm reading this stuff here, and this is confusing. Once you start getting into the later parts of the book, usually what I found is that the lecturers, they're just focusing on chapter 1 to 5 or something like that. So it's very rare that they're gonna, because if you think about it, the last chapters in the book are the most advanced and stuff like that. So if they wanted you to learn that, they would just find a book in which those last chapters were the beginning chapters of another book, and then explained more basically. So okay, so let's just take a look at now what Google has to say about analog electronics. What subjects are in analog? Common core subjects include solid state device fundamentals, feedback amplifier analysis, frequency response of BJTs and amplifiers, hands-on lab experience with working with op amps, JFETs, preamplifiers, diodes, and transistors. Okay, so yeah, I'm looking forward to that. I have a bunch of transistors on my desk, but I haven't really been confident enough to give a go at using them on a breadboard yet. Okay. What do Indian students hate the most? I'm not even gonna try and answer that. I was about to be racist. Okay, or not really racist, but stereotyping. Okay, what are some must-have books on analog electronics? How can I must-have in 1 week? Bloody hell, this guy's dedicated. Even for a genius like yourself. Good answer. I am a master analog electronic engineer. You're never going to learn it all to master level in 1 week or even 1 year. That is hilarious, man. What kind of a question is that? What is analog and digital electronics? If analog, all values are actual numbers, 0 through infinity, positive. You're just talking about discrete and stuff, aren't you? Yeah. Okay, so yeah, I'm super happy with that. So I've got a nice. Now, when you look through here, you've got a nice amount of subjects, to go through, and as I'm studying over the next 3 weeks, I can pretty much pick any of these subjects and just go and start studying them, and it's going to really, really help me. So what I'll do is I'll try and record some videos moving forward of me getting ready, for my second year, as in going through the modules and when I actually begin studying. So if I have time, I don't know if I will have time, but if I do have time, then I'll record some videos of me actually studying these modules. But for now, you've seen in this video, this has been a deep dive into each one of the modules. And you can see if you watch my last video, I really didn't, when you look at the official descriptions, so for example, we go back to here, this is what we did in the last video. Literally, when you look at this here, investigate the principles and applications of modern communication systems from satellite to wireless systems. You examine real-world case studies in order to develop your scientific, engineering, and mathematical knowledge. Like, what? That's communication systems. That's useless to me. Instrumentation and control. Apply the theory of device control on a variety of systems. You investigate the theory, properties, and fundamentals of control systems. And again, so from doing this in my last video, and now what we've got in terms of all of this, when you look at instrumentation and control, I feel so much better about what I'm going to learn. So yeah, thanks for watching, guys, and I shall see you in the next one. Peace.